Alright, some more angular kinematics. Alright, so let's see, we're trying to find time here. It gives us the initial speed, the final speed, and the acceleration. So I think you're going to use omega f equals omega I plus alpha t. So Vf equals Vi plus At. Here's Vf, here's Vi, here's A, is alpha t. Okay, so we can use this information here about Jupiter to figure out what its angular speed is. So we can use d equals v bar t. D would be 2 pi radians. The omega here is going to be our initial angular speed that we're going to be finding, and the time here has to be in seconds. Once we know that, then we can use Vf equals Vi plus At. The final is going to be 0. The initial is what we just found. The acceleration is this amount here, and solve for time, how long it takes to come to a stop. Okay, we're going to use the same idea. It's going to be omega f equals omega I plus alpha t. So Vf equals Vi plus At. We know what Vi is. Here's Vf. We know the time. Solve for the acceleration. Okay, same idea. Vf equals Vi plus At. It starts from rest, so Vi is 0. It tells us the acceleration. It tells us the time. You're supposed to find the final angular speed. Same idea for this one. Vf equals Vi plus At. Initial speed is 0, so that drops out. We know the acceleration. We know the time. Find the final angular speed. Same idea for this one. Initial speed is 0. Final speed is this amount. Here's the acceleration. And find out the time. Right. Same idea. We've got the initial speed, final speed, acceleration, find the time. This is an interesting device. This is called a governor. So for engines at one time, you don't want them spinning too high of revolution. That can actually cause damage. And because of inertia, these balls that they're spinning, they swing out. And by swinging out, this lever then will control the flow of fuel or whatever to the engine, which will throttle it back down again. So it governs how fast the engine's working. Anyway, we're trying to find the acceleration here. We know the initial speed, final speed, and the time, so find the acceleration. Okay, we know what the initial speed is. We know what the time is. We know what the final speed is. Find the acceleration. Okay, so for this, I think what we want to do is we want to find the two speeds of Earth. Okay, so now, if I want to find the speed now, the 24-hour one, the angular distance we spin through is 2 pi radians. This will be, by the way, the final angular speed for Earth. And this time we had to convert into seconds. And so we can figure out what the speed is now. And then we can do it 70 million years ago. So again, this will be 2 pi. We'll call this omega I. And we have to convert this time into seconds, and so you can figure out what the initial angular speed is. And then finally, we can use VF equals VI plus AT. We know what the VF is, we know what the VI is, and for the time, we had to convert this time into seconds, this 70 million years into seconds, and then you could find the acceleration.